What's up, guys? That is day 81 of the 100 Days of LeetCode. We got a medium problem. That's jump game 2. I did jump game on this channel a long time ago. If you haven't checked that out and you want to check that out, link's going to be in the description. If not, let's get right to it. So we're given an array of non-negative integers nums, and we are initially positioned at the first index of the array. Each element in the array represents your maximum jump length at that position. Your goal is to reach the last index in the minimum number of jumps. And you can assume that you can always reach the last index. Okay, so let's look at the example. So here we have this list, and we can reach the last index in 2 jumps because we start at this one at the 0th index. We can now jump to either the first index or the second index, right? Because the maximum we can jump is 2 indices. So to reach the end in 2 steps, what we do is we jump 1 step to the first index, and then from here we jump 3 steps to the last index. So that's why we output 2, and the explanation basically goes over what I just said. Now, example 2, again, we can reach it in 2 steps, and the reason being is because we can, of course, just jump 1 step to the first index, then jump 3 steps to the 4th index. I wish they would have put a different example, and these ones are actually just very similar. They just swapped the 0 and the 1, but you know, what can you do? Anyway, let's get to the solution. So the first thing that we need to do is we're going to create a variable. We're going to call it jumps. This is going to keep track of the number of jumps. Now we're going to create 2 variables, LP and RP, and they're going to stand for left pointer and right pointer. We're going to set them equal to 0. So what these 2 variables are is basically this. So imagine we're at the 0th index here, right? Well, we can jump to the first index or the second index, okay? So these variables are going to represent sort of the left side and the right side of the current, or I should say the next window that we can jump to. So we're going to basically be updating these throughout sort of the loop that I write in a second, so that basically we're just going to keep track of the left side of the next window and the right side of the next window. And then based off of those values, we're going to slowly, well, I guess not slowly, it's computer, so it's fast. We're going to increase them, and eventually we'll know the number of steps that it'll take to reach the end. And I'll show you how we do that. So we want to basically keep going while the right pointer is less than the length of nums minus 1. Okay? And the reason why we're doing less than the length of nums minus 1 is because after every single iteration of this loop, the right pointer is going to shift. So we do not want to keep going while the right pointer is either at the end of the list or obviously past the end of the list, because that would mean that we've already reached the end of our list and we can finish then, right? So that's why we're going to do less than the length of numbers minus 1. Okay, so what we do here is we are going to create a variable called max index. We're going to set this equal to 0. Now this variable is of course going to be created in every single iteration of this loop, and what we're going to do is we're going to say for I in range, left pointer, right pointer plus 1, we are going to update the max index to be the maximum of our current max index, or basically a farther index that we could jump to. So what we're doing here is we're basically checking, okay, what is the farthest index that we can jump to within this one window, right? So let's go back to this example. If this is our window, our left pointer is index 1, our right pointer is index 2. We want to find out what the farthest index that we can jump to is from within that window. And of course, it's going to be index 4 in this particular scenario. But, you know, you might have scenarios where the window is larger and, you know, this code is going to work for everything. So we start with a max index of 0. And then we basically check whether or not our current max index needs to be updated to I plus nums I, which of course is basically the current index that we're at plus how much we can jump from that index. And of course the index is represented in this loop by I. Okay, so once we're done that loop, What we need to do is we need to update our left pointer, and that's going to basically be the right pointer plus 1, and our right pointer is going to be our max index. Okay, and then we're going to increase our jumps. We're going to return jumps. Okay, so the reason why we're increasing our left pointer to the right pointer plus 1 is because, of course, our left pointer is just going to be the number immediately to the right of our previous window, and our right pointer is going to be represented by the max index that we calculated up here. And then, of course, we are going to update or increment, I should say, our jumps, because every single time we go through this loop, it's going to represent 1 jump. And I think I explained anything. One thing that I don't think I explained is the reason why we're putting this plus 1 in this range is because, of course, we want this iteration to include our right pointer. And the range function in Python is, of course, the second argument is exclusive. So we have to put plus 1. Now we can submit our code and it should work. Okay, so there you go. That's how we solved that one. That was day 81 of the 100 Days of LeetCode. We got another 19 days to go. Please like, subscribe. We'll see you tomorrow.